now need to discuss the possibilities when we still have two events, but we have two separate options. We are going to have something called with replacement and without replacement. So when we have these options, if it is with replacement, that means they are independent, meaning that there is no bearing on each other. And I cannot write while I'm trying to talk. I apologize. Okay. So, and the reason why they're independent is because whatever happens the first time, if you replace that object, the probabilities are back to the same. Let's look at a deck of cards. So here's a deck of cards. Some of you may or may not be familiar with the deck of cards. There are a total of 52, provided you take the jokers out, in a standard deck of cards. You have the diamonds, the hearts, the spades, and the clubs. And so you have 4 different suits. You have an ace through 10, and then you have a jack, queen, and king. These right here are what we consider our face cards, ones that actually have faces on them for our purposes anyway. There are 13 cards for every suit. Okay? So if I think about this, and I want to draw 2 cards, and I do it with replacement. So I'm going to draw 1 card, and then I'm going to look at it, and then I'm going to put it back in the deck. And I want the probability that it's a 7. Okay. So let's say I draw a card and I get the 7 of hearts. I look at it and it's 7 of hearts. Okay. Well, I put it back. What was the probability of me getting that 7 of hearts? Well, it was 4. Well, let me just say a 7. It was 4 out of the 52. Okay. Since I put it back, how many cards do I have to draw from again for the second time? I still have 52 cards to draw from. How many 7s are still left in my deck? There's still 4 of them. And so whenever we do that, we're going to have 4 over 52 times 4 over 52, which will simplify into 1 over 169. That is with replacement because I put it back. My probabilities did not change. Okay? Even if I said the probability of drawing a heart on the first, then an ace. If I'm doing it with replacement, I have 13 hearts to draw from to begin with. So that's 13 out of 52. If I draw a heart and I put it back, then I still have 52 cards to draw from. And even if it was the ace of hearts, I still have 4 aces to draw from. So I don't have fewer cards to draw from or anything. It's just that I'm doing multiple actions, and I will get 1 out of 52 for this. Now, if I do this without replacement, I have to look at the probability of event B times the probability of event A, given that B has already happened. Or you can look at it as the probability of event A times the probability of event B, given A has already happened. Either one. The first object, it has its normal probability. The second one you have to look at as the first one has already happened, so you have some given information about it. Again, let's look at the deck of cards. This time, we are going to do it without replacement, okay? And so, let's look at both of these possibilities. Or let's look at the probability of drawing a 7 without replacement. Now, on the first draw, and I'm going to move this down a little bit so that I can look at it a little bit better. Probability of a 7 without replacement. So on the first draw, I have 4 7s to draw from out of the 52. Okay, so I draw a 7. I look at it, and I don't replace it. So that card is gone. I no longer have 52 cards to select from. I now only have 51 cards to select from. And now how many 7s do I have to select from? I actually only have 3. Given that I have already selected one of those 7s, I now only have 3 7s left to select from. And so this is where knowing whether you are doing things with or without replacement is going to change what happens on that second time. Let's look at a jar that has marbles, okay? So I have this jar or this box, and I'm going to put some marbles in it. So I'm going to put 5 of that color, and I'm going to put 4 of this color, and 1, 2, 3, 4, 5, 6, and 7 of this color. Okay, so let's see here. That should give me 16 total. So I currently have a total of 16. So I want to know the probability of drawing a red first, then a blue second. So my probability of drawing a red first, well, I have 5 reds. So that's 5 out of 16. So that means if I draw a red, that 1 has gone away. So I no longer have 16 to select from. I only have 15 left because I got rid of that 1 red. I still have 4 blue to select from, but now it's only out of 15. So notice that drawing a red first didn't change my numerator for my blue, but it still changed my denominator. Let me make sure that I put a without replacement here. Okay? Because if I did replace that red one, then I would have 4 out of 16. But this time I'm not replacing it. So I want you to look at some of these that have with replacement, without replacement. Look at your deck of cards and see if you can do some of these probabilities, and then let me know if you have questions.